This section is what you all have been waiting for. Passkeys, a new shiny passwordless technology, is a revolution in authentication that brings both security and usability to everyone. As we know from the previous topic, FIDO2 laid fundamentals for passkeys, so we first explore the extra features designed to improve usability and encourage adoption. Then we'll take a closer look at their security model, examining what works well and what challenges remain. Finally, we'll wrap up by comparing passkeys with other authentication methods we've covered, assessing their strengths in security and usability. Let's jump in. Without further ado, let's define what passkeys actually are. In simple terms, passkeys are like FIDO2 with a few small updates. You might wonder, why not call them FIDO3 or FIDO 2.1? Well, the name Passkey was chosen to make it easier for everyone to understand and adopt. The idea is simple: replace a password with a passkey. Think of it this way: instead of typing in a password, you use a key, much like the key you use to unlock your house or car. The name Passkey makes it easy to understand what's happening without diving into the technical details. This approach also helps address the challenge of getting non-technical users on board quickly. By using a simple and intuitive term, it's easier to explain and adopt the concept of passwordless authentication. Passkeys also create a standard way of talking about passwordless solutions based on FIDO2 technology. It brings all the major vendors together under the same message, making it easier for users to recognize and trust. To make things even simpler, passkeys come with consistent designs and icons that help users visually connect with this new, secure way to log in. Are passkeys and FIDO2 the same thing? Not exactly, but they're very similar. If you remember our earlier discussion about FIDO2, most of what we covered still applies to passkeys. Specifications, how authentication works, and the message flows are all the same. So what's the difference? The big change is how passkeys handle keys. With FIDO2, one of the challenges was its strong security property that made it impossible to export keys. While this enhanced security, it also created usability issues, such as difficulties with recovery or migrating authenticators. Passkeys changed that by relaxing the rules allowing keys to be exported. This increases the risk of the private key being stolen, but it also makes recovery and migration much easier. It's a classic trade-off. Some security is sacrificed to improve usability and encourage more people to adopt the technology. Ultimately, this makes the average user's authentication far more secure than sticking with passwords. Because of this new functionality, you might hear terms like synced passkeys or multi-device passkeys. These refer to the ability to share keys across devices. For example, if you create a passkey on your phone, you can also use it on your computer. This works similarly to how cloud-based password managers sync passwords across all your devices. But wait, if passkeys behave like password managers, why not just stick with passwords and rely on the password manager? At first glance, they might seem similar. Password managers can even offer extra protections, like warning you if a website's domain doesn't match the saved password. However, passwords still have all the issues we've discussed before, even when managed properly. Passkeys, on the other hand, are secure by design. By switching to passkeys, you eliminate many modern attack vectors and enjoy a simpler, safer way to log in. How many types of passkeys are there? Not too many, but the names can be a bit confusing since they all refer to passkeys with different features. Passkeys can be designed and configured in various ways to offer specific functionalities while still staying compliant with the FIDO2 specification. Let's break down the Passkeys dictionary. Synced passkeys. These are passkeys where the private key can be backed up or copied to another device. This makes it easy to recover or use the same key across multiple devices. Multi-device passkeys. These are essentially the same as synced passkeys. The same key is shared across multiple devices and can be used simultaneously. Device-bound passkeys, or single-device passkeys. These are the closest to the strict FIDO2 setup. The keys are created and locked inside the authenticator, and they cannot be exported or shared between devices. Passkeys with discoverable credentials. These passkeys hold user identity information and can be discovered by the client. This means users don't need to enter a username. It's sometimes called usernameless authentication. It also lets devices show a list of credentials for users to choose from. Non-discoverable credentials. These are not really considered passkeys because they require the user to provide additional information like a username and must be explicitly requested from the FIDO server. Platform authenticators. These are built directly into everyday devices like phones or PCs. They rely on the device's secure hardware to handle FIDO2 operations. Roaming authenticators or cross-platform authenticators. These are external devices like USB security keys that can be used across different platforms to authenticate. Sync Fabric. This is the technology that allows synced passkeys to be synchronized across devices. It can be built into a platform like Apple's iCloud keychain or provided by independent tools like password managers. This quick overview should guide you as you explore different passkey options. Let's take a closer look at synced passkeys. The ability to move a private key from one device to another is a huge usability improvement. But doesn't having the private key floating between devices create risks? Couldn't someone use it to impersonate you? You're absolutely right, it's a potential risk. That's why passkey synchronization is such a sensitive process. Protecting passkeys during recovery or transfer now becomes the responsibility of the passkey authenticator vendor. For example, companies like Google and Apple have integrated this feature into their account management systems, making it easier for users to recover their passkeys. But can we just trust the vendors and not worry about security? Even with reputable vendors, it's important to ask how they're protecting your synchronized passkeys. Is the synchronization process as secure as the passkeys themselves? Or could a phishing attack compromise the system and steal your private key, bypassing all the security features of passkeys? Even with thorough research, finding clear answers to these questions isn't always easy. This is made more challenging by the fact that, as of early 2025, there's no official standard for passkey synchronization. As a result, synchronization is currently limited to the same vendor's ecosystem, which reduces the usability of passkeys and raises concerns about vendor lock-in. Fortunately, the FIDO Alliance is working on a new protocol to create a standardized cross-platform synchronization solution. Let's take a moment to think about synced passkeys and how they fit into multi-factor authentication. Does syncing passkeys between devices change how we categorize them? It's an interesting question. There's a bit of a gray area here. Traditionally, FIDO2 keys are tied to a specific device, which makes them count as something you have. But if a key can be copied or transferred between devices, is it really that different from a password? This might sound like a technical debate, but it's actually important if you're trying to follow internal security policies or meet external certifications. This issue is so important that the US National Institute of Standards and Technology addressed it in their guidelines. These guidelines outline the assurance levels for different authentication methods. Under certain conditions, synced passkeys can achieve level 2 out of 3 assurance levels, similar to multi-factor OTPs and multi-factor cryptographic devices. Let's pause for a moment to talk about usability of passkeys. As we already know, synchronization has made recovery and migration much simpler, but what about the platforms? The major tech companies now support passkeys, offering both authenticators and client implementations. For example, if you're using a Windows PC, your device itself can act as an authenticator, while Windows Hello works as the client. This creates a seamless experience for users on this platform. No matter which browser you're using, the system hands control over to Windows Hello, where you can choose your authenticator, either the built-in one or an external device. But what happens when you need to use passkeys across different devices or platforms? There is a flow for this. It is called hybrid flow, and it uses Bluetooth to connect devices. Here's how it works. When you start a Passkeys transaction, a QR code is generated. You scan it with a device that has the authenticator, like your phone. The devices, say your laptop and phone, then perform a close proximity verification using Bluetooth. Once checked, both sides know how to securely communicate and exchange FIDO2 messages. Keep in mind, though, that as of 2024, this flow is still new and might not be supported on every platform. Let's see how the hybrid flow works. In this demo, we're using the webauthen.io platform, the Chrome browser on a Mac, and an Android phone as the authenticator. We'll first register a passkey on the Android device and then use it to log in. To start, the user enters a username to link with the passkey. The browser then displays a QR code. The user scans this QR code with any QR code scanner on their phone. The code contains a URL that tells the Android device to start the Passkey setup process. The phone and the computer communicate first through Bluetooth and then switch to WebSockets. Once the connection is established, the Android phone follows the standard Passkey creation process, including user verification. The user verification step isn't shown in the recording for security reasons. Now let's log in. The browser shows another QR code which the user scans with their phone. Again, the devices establish a connection. Since there's only one passkey registered, the phone goes straight to user verification and authentication. The response is sent back to the browser and the user is logged in successfully. During the process, you can use the remember function so that next time you don't have to scan the QR code and devices can connect automatically. Let's look at the user experience. When we compare traditional password-based logins where you type in a username and password to Passkeys, Passkeys are an obvious winner. However, when we factor in the autofill feature for passwords, things get interesting. With autofill, logging in becomes very simple. The user visits a login page and the browser or password manager detects the input fields. It automatically suggests the right credentials and fills them in. From the user's perspective, the process involves just selecting the credentials and clicking log in. So now the Passkeys flow might not seem as seamless, but they also have an autofill feature. In this case, the browser contacts the authenticator, such as a phone or security device, to check which passkeys are available for that page. The authenticator provides a list of account names. Then the user simply picks the correct one and the browser runs the authentication flow. This process doesn't even require a username, as the passkey is already tied to the account on the server. While this passkey autofill flow is a big step forward in usability, it does have some constraints. This feature relies on discoverable credentials, and the authenticator needs to be available, which can be a challenge for roaming devices or when logging in across different devices. Additionally, discoverable credentials can sometimes reveal that you have an account on a particular website, raising potential privacy concerns. Let's check out a demo of the autofill feature. In this example, we'll use the webauthn.io portal, the Chrome browser, and a hardware token with a fingerprint scanner. First, we register a passkey using the username Michael3. The browser prompts us to scan our fingerprint, and once that's done, the registration is complete. Now, instead of entering a username, we can simply click the Use a Passkey option. At this point, the browser tries to find stored credentials on the authenticator, so it asks for fingerprint verification to unlock it. Once the fingerprint is verified, the browser retrieves the list of stored credentials and displays them. Here we can see multiple passkeys, including the one we have just created. The user selects one of the credentials, and this initiates the authentication process. As you can see, the entire login process happens without entering a username. Now it's time for security. Passkeys inherit the FIDO2 features except for the private key security model. Let's iterate over them to have a complete picture. When you register a passkey, only the public key is stored on the server. This means that even if the server's database is leaked, there's no risk, as public keys are only used for verification. Thanks to cryptography, the private key can't be derived from the public one. Passkeys are built on FIDO2's secure foundation, following open and standardized protocols like CTAP and WebAuthn. They use digital signatures with industry-standard cryptographic algorithms, leaving little room for insecure or custom implementations. Next is domain verification. We discussed it in depth when we analyzed adversary and the middle attacks. It allows the passkey transaction to validate if the authentication domain is the same as the one during registration. If not, the flow terminates with an error. Storage of the private keys is typically integrated with the platform security elements. However, for passkeys, storage needs to be adapted to support the synchronization. So we need to cross out the FIDO2 strong property of private key security. Another related aspect is that in FIDO2, it is not possible to reuse credentials, but with Passkeys, this is actually a feature to be able to use multiple devices for authentication. Finally, we have user verification mechanism. Biometric or PIN-based mechanisms run locally to unlock the private key in the authenticator. While there's more to discuss, these key features show that Passkeys strike a balance between security and convenience. When thinking about security, you might wonder, if it's possible to transfer a key to a new device, how can you be sure an attacker hasn't found a way to copy your key and use it to impersonate you? From an organization's perspective, there's also the question, how can you tell if a user has switched to a new device? Unfortunately, the current version of the protocol doesn't have a way to address this. While the issue has been discussed in working groups, the protocol doesn't provide a mechanism for the server to distinguish between transactions from an old device and those from a newly synced one. Essentially, the only control over this process lies with the device vendor. However, as we've talked about before, you can choose to use device-bound passkeys, which follow the FIDO2 standard's strict rules against key extraction. By enforcing this on your FIDO server, you can reject passkeys that allow private keys to be synchronized between devices, giving you greater control over security. Let's summarize everything we've learned in a single diagram. Imagine a line that represents the strength of authentication. A quick disclaimer, this is a subjective view and you might find reasons to rank some methods differently. Starting from the weaker end, passwords are generally the least secure option. Moving up, we have one-time codes like those sent via SMS, email, or TOTP apps. A step further brings us to push notifications, which provide slightly better security. Combining multiple methods into multi-factor authentication improves security even more. Beyond that, synced passkeys offer a strong solution, and at the very top are device-bound passkeys providing the highest level of security. When we consider usability, the picture shifts. Passwords are relatively simple for users, but one-time codes introduce friction with their manual steps. Push notifications are more user-friendly, while MFA, despite its strength, can feel cumbersome. Synced passkeys clearly stand out as the most user-friendly option, while device-bound passkeys, though highly secure, trade some convenience for that added protection. This evaluation highlights the appeal of passkeys, offering both strong security and good usability. So now you can make an informed decision what is needed for your use case. Do you need a strong authentication method for your personal social media accounts? Then using Passkeys is a good choice. Do you need a strong security authentication for engineers to access a production system with financial records of thousands of your clients? Well, in this case, FIDO2 with device-bound keys and user verification looks like the best choice. Ultimately, the decision depends on your specific needs, existing technology, and constraints like budget and user experience expectations. With this perspective, you're better equipped to choose the right approach for your situation. Let's quickly recap what we covered. We started by explaining how Passkeys evolved from FIDO2, keeping its core features but rebranding for better adoption. Then we explored the different types of Passkeys, their environments, and the terminology used to describe their features. Next, we highlighted the new security features Passkeys bring compared to FIDO2, focusing on their strengths while noting a few limitations. Finally, we compared all the authentication methods discussed in this course, weighing their security and usability. Passwordless authentication is rapidly gaining traction, with platforms increasingly adopting passkeys for both workplace and personal use. This is a major leap in cybersecurity, which makes authentication more secure and user-friendly. I hope this course gave you a clear understanding of modern authentication methods and inspired you to switch to more secure solutions if you haven't already. Now that you know how passkeys work and why they're safer, you can encourage their use among your family and colleagues. Thank you for watching.